Okay, so as a final example on computing probabilities in discrete sample spaces where the outcomes are equally likely, we're going to have, as our experiment, we're going to toss, and I'll highlight this, we're going to toss 3 fair coins, and we want to list out the sample space and then find a couple of probabilities. So let's go ahead and start by listing out the sample space, and I'm going to show you how to use a tree diagram to list this sample space out. So for part A, our sample space. So we're going to have 3 tosses. So on the first toss of this coin, we're either going to get heads or tails, H or T. On the second toss, we're going to draw some additional branches. So if we got a heads on the first toss, on the second toss, we could get a heads or a tails. So we add some branches for the second toss. And if on the first toss we got a tails, then on the second toss, we could get a heads or a tails. And then finally, one more set of branches for the third toss. We're going to get heads, tails, heads, tails, heads, tails, and heads, tails. So to get all of the outcomes, we just need to follow these branches across. So for this first branch, we're going to get heads, heads, heads. That's an outcome. So I'm going to write that to the right. The next branch would be heads, heads, tails, heads, heads, tails, and then heads, tails, heads, heads, tails, 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 heads, heads, tails, 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 sorry, tails, heads, tails, 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 heads, TTH, and TTT. So this is our sample space. It's not, I guess we could put some brackets and commas if we wanted to make it a little more rigorous. But we basically have 1, 2, 3, 4, 5, 6, 7, 8 equally likely outcomes in our sample space. So here we have 8 outcomes in S. So we can calculate the probability. Okay, so the first part was to list S. And so let me just go ahead and list it. S equals, carefully, H, H, H. So just listing this column on the right, H, H, T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, and T, T, T. 2, 3, 4, 5, 6, 7, 8. So I just want to make sure I got everything. And so the first, that's the answer to part A. The second part asks for us to compute the probability of exactly 2 heads. So let's say event A be exactly 2 heads. So this is what the event A looks like. And I'm just going to circle those outcomes exactly 2 heads. So HHT, HTH, THH, and those are the only ones. Okay, so HHT, HTH, and THH. And actually, you just need to count how many there were in there if we want the probability of event A. It's the number of outcomes in A divided by the number of outcomes in the sample space, which would be 3 over 8, or 0.375. For letter C, we were asked to calculate the probability of exactly 1 heads. And so that is the probability of the set. Let me circle these in purple. Exactly 1 heads would be this outcome, and this outcome. So let me just actually compute the probability. So there are 3 outcomes out of 8 where there is exactly 1 heads. Actually, did I say? Sorry, I said at least 1 heads. So let me correct that. At least 1 heads. At least 1 heads would be all of the purple outcomes that I already circled. Those have exactly 1, plus the outcomes that have 2 or 3 heads. So HHH, HHT, HTH. Okay, so the only one it would not include is TTT. So there are 7 here. 7/8 is going to be my answer.